All right, so you should be on page 15 of your notes. We're going to be talking about multiplying radicals today. We already kind of saw a briefing of it the other day where if you have two separate square roots, it's kind of like, you factor something out. Basically, you're unfactoring it. So instead of breaking it apart, you're putting it back together. So we have the square root of 3 and the square root of 6. We're kind of wanting to compile this all together under one radical. So it now becomes the square root of 3 times 6. And what is 3 times 6? 18. So now we have the square root of 18. But you guys should be looking at that and going, it's not final. Why? Because you can simplify it. What perfect square can go into 18? 9. So we got that square root of 9 and that square root of 2 that we can factor it apart. Okay, now keep in mind again, square root of 9 is your perfect square. So I'm going to go ahead and circle that one in the pink. And that would give me what? 3. And then the square root of 2 right behind it. So we get 3 square roots of 2 and then you are done. So if you multiply square root of 3 times square root of 6, your final answer is 3 square roots of 2. Try this one on your own. Square root of 8 times the square root of 6. All right, who can raise their hand and tell me what they got when you multiply square root of 8 times square root of 6? Ethan? 4 square roots of 3. Very good. So again, if you compile it together, multiply them, 8 times 6 is going to give you what? 48. So now you have the square root of 48, but 48 can be simplified. You can factor it out. What perfect square is going to go into 48? 16. So we have the square root of 16, and then it's multiplied by the square root of 3. Again, 16, that's your perfect square. So the square root of 16 is going to equal 4. So you get 4 square roots of 3. And then you are done. Okay, now let's go ahead and ramp it up just a smidge. We're going to add some variables and some components that are on the outside. Can I multiply a value that's outside the radical with a value that's inside the radical? No. One of them is outside, meaning that it has already been square rooted, and the other one is inside, meaning that it is yet to be square rooted. So you cannot multiply a 2 with anything in here, but if we happen to pull something out, we can then multiply it by the 2. So if we rewrite this, we already know that the 2 is going to be on the outside. It has already been square rooted. I'm going to put it in that pink so that I know that it's done. I don't touch it. Okay? Then, if I piece everything together here, this is the same thing as saying I'm going to do 8x times 4x. Now remember, when you multiply numbers by numbers and variables by variables. So again, rewrite that as 2 separate square roots. We have the square root of 8 times 4, and we have the square root of x times x. Well, what's 8 times 4? 32. So we get 2 square root of 32. And then what's x times x? X to the second power. So now we have the square root of x to the second power. Okay, 32, can we factor it? What can we break it up in? 16 and 2. So square root of 16, square root of 2. Now, I still have that 2 that's in the front. Square root of x squared. Is that a perfect square? Yeah, so I'm going to leave it alone. I'm not going to factor it out. I'm not going to break it apart. Now I'm going to go ahead and identify all the perfect squares that I have here. 16 and x squared. Those are my perfect squares. So I have my 2 times, what's the square root of 16? 4. What's the square root of x squared? X. So we have 2 times 4x, and then what's the only thing remaining? Square root of 2. All right. What's 2 times 4x? 8x. So now we have 8x, square root of 2. And you're done. Ramped it up just a little bit, but it's not that hard. Try this one on your own. You have the answer? Okay. What'd you get, Rashawn? 6m squared root of 7 is correct. All right, so let's take a look at it. Okay, the 3 has already been square rooted, so it's already on the outside. We're going to combine everything together on the inside of your radical. So we have 2m times 14m. Again, we can break it apart even further so that we have just a radical for the values of that are numerical. So 2 times 14. And then a radical that's just for the variable, m times m. What's 2 times 14? 28. So now we have 3 square root of 28. What's m times m? M to the second power. All right, let's factor it out. What factors are 28? 7 and 4. So 4 is your largest perfect square that can go into this 28. 4 times 7. So you have the square root of 4 and the square root of 7. Still have that 3 on the outside. M to the second power, is that perfect? Yes. So we're going to go ahead and, leave it alone. We don't have to factor it out. Okay. Our perfect squares, we've got square root of 48, or sorry, square root of 4 and the square root of m squared. That becomes 3 times, what's the square root of 4? 2. What's the square root of m squared? M. And then we have square root of 7. And then what's 3 times 2m? 6m. So we get 6m square root of 7 as your final answer. Any questions? All right, let's ramp it up a little bit more. You're going to, again, do this next one on your own. Page 16, problem number 5. Not too hard, just a little bit more to it. Instead of, x and x, it's x to a power and x. Try that one. Yeah. You got it? Hold on. Very good. All right. 6x squared, square root of 5x is the correct answer. All right, so when we go on to this, again, that 2 is already been square rooted, so it's going to stay remaining on the outside. Inside, we're going to wind up having 15x to the 4th times 3x. Break it down a little bit further, and you're going to have 2 square root of 15 times 3 and square root of x to the 4th times x. What's 15 times 3? 45. So we're going to have the square root of 45. And then x to the 4th times x? X to the 5th. Okay, so you get x to the 5th. Now, factoring it out, 45. What perfect square goes into 45? 9. So you have square root of 9 and square root of 5. So you have 2 square root of 9, square root of 5. And then x to the 5th has to be broken down, doesn't it? Which originally we already had it kind of broken down, so we could have technically left it that way. X to the 4th and then x. Okay, but it won't always be like that. Sometimes you might need to combine first and then break down separately later. All right, which ones are my perfect squares? 9 and x to the 4th. Okay, so that gives us 2 times what? 3 what? 3x to the second, right? X to the fourth now becomes x to the second. You just divide that exponent by 2 and you get x to the second. What goes inside the radical? 5 and an x. Okay, what's 2 times 3x squared? 6x squared. Good. And then square root of 5x. And that's it. All right, one more. This one is a little bit different. Before, we either had just radicals without any value that's been pulled out, or we just had one value that was pulled out, and that's it. Here, if I give you 5 square roots of 15x to the third, and I want you to multiply it by 2 square roots of 5x to the fifth, what do you think you do with those numbers? You can multiply those numbers together. Anything that is outside, if you're doing multiplication and they're both outside, you can multiply those together. Just like when we sat here and we pulled these numbers outside, we now pulled a 3 outside, we then multiply it with anything else outside. So try this one. right, who can raise their hand and tell me what they got? Alicia? Very good. 50x to the fourth square root of 3. So if we take a look at this, again, when we break this apart, we have that 5 times the 2 that can come out into the front because both of those are already perfect and they've been square rooted, so they're already in the front. Here, we can have the square root of 15x to the third times 5x to the fifth under one house. Break it down a little bit further. This is going to give us 10 square root of 15 times 5 square root of x to the third times x to the fifth. What's 15 times 5? 75. So now we have 10 square root of 75. And then x to the third times x to the fifth? X to the eighth. Just add those exponents together. Okay, 75, we can break it down to what? 25 and 3. Good. Square root of 25, square root of 3. X to the eighth, do we need to break that down? No, it's already perfect. It doesn't need to be broken down any further, so we don't have to factor it. We'll just eventually simplify it because that is one of the perfect squares. Square root of 25 is perfect. Square root of x to the eighth is perfect. That brings the 10 times 5, and then this is x to the fourth. Then we have our square root of 3. Then just multiply these together. What's 10 times 5x to the fourth? 50x to the fourth. And then square root of 3. All right, any questions? Okay, so you have a homework assignment that's going to go on page 17 of your booklet. You'll just glue it in. You're going to glue it in onto page 17. Hold on.